I'd like to do a few more examples now where we're simplifying expressions that have exponents, and specifically negative exponents in addition to positive exponents. So let's start with a refresher of what we were working on in the previous video, and that is that if we have 5 squared, we get 25. If we have 5 to the first, we get 5. If we have 5 to the 0 power, we get 1. The pattern here is that as the exponent decreases, we're dividing by 5 each time. So as we continue and we go 5 to the negative 1 power, well, we do 1 divided by 5, we get 1/5. 5 to the negative 2, we divide by 5, and we get 1/25. So if we want to write 5 to the negative 1 as an expression with positive exponents, we can write that as 1 over 5 to the positive 1. 5 to the negative 2 is 1 over 5 squared, or 1 over 25. That means that when we're dealing with something like 2 times x to the negative 5th, x to the negative 5th is really 1 over x to the positive 5. So we can write this as 2 over x to the 5th. So let's get back into some examples. Our first problem today is 3m to the negative 4th divided by m to the 3rd power, or m cubed. Let's break this down a little bit since we're just easing back into this. 3 times m to the negative 4th times 1 over m cubed. I've broken out each part, each factor that was a product of this original expression. 3 we can leave alone. M to the 4th we want to write now as 1 over m to the positive 4. And 1 over m cubed we can leave as 1 over m cubed. We want to get this negative exponent out because we usually don't like to write them in our expressions. Well, now we've got 3 times 1 over m to the 4th times 1 over m cubed. If I multiply together these two fractions here, I'm going to have 3 times 1 over m to the 4th m cubed. How many m's are multiplied together in that denominator? Well, here there's 4 of them multiplied together, and here there's 3 of them multiplied together. So there's a total of 7 of them being multiplied together. And I can simplify this even further by combining those two back together and saying 3 divided by m to the 7th is my final answer. So let's get a little bit more complex. 4 times x to the 0, y to the negative 2, z to the 3, all over 4 to the x. Let's take each thing a step at a time. I'm going to separate them out by like terms. So I'm going to put the x's together, I'm going to put the y by itself, and the z by itself because they don't have any corresponding y or z's in the denominator. I'm going to simplify each of these separately and then multiply them back together. 4 divided by 4 is 1. That was easy enough. X to the 0 over x to the 1, right? This is x to the first power. Well, if I'm dividing two terms with the same base but different exponents, I'm going to subtract those exponents. So this is x to the 0 minus 1. Then we've got y to the negative 2 times z cubed. I'm going to not write this 1 anymore because if I'm multiplying 1 by something, I'm going to get that something. So I don't need to write the 1. It's not necessary. We have x to the negative 1 power, y to the negative 2, and z to the 3rd power. Well, the whole point of this is that we wanted to get rid of these negative exponents. X to the negative 1 can be written as 1 over x to the positive 1. Y to the negative 2 can be written as 1 over y squared. And z to the 3rd doesn't need to have anything done to it because it already has a positive exponent. But for the sake of some clarity here, I'm going to write it as over 1. So when I think about multiplying all three of these terms together, I can see across what the numerators are and across what the denominators are. So speaking of which, in the numerators, 1 times z cubed is just z cubed. The denominators, x to the first is just x times y squared is xy squared, times 1 is xy squared. So x times y squared in the denominator. Z cubed over xy squared is our final answer. Let's look at doing that problem again, but a little bit faster this time. So our problem said 4x to the 0, y to the negative 2, z to the 3 over 4x. Well, I know 4 divided by 4 is 1. Let's cancel those out immediately. X to the 0 is also 1, so I can ignore that. This is x to the 1 in the denominator. I can leave it there. The only thing now that needs to be moved is y squared, y to the negative 2, because it's a negative exponent. So I can leave my x in the denominator and pull down the y squared. That took me one step thinking it through rather than the entire page of work we did for working it out step by step. I want you to know how to work it out step by step because these are going to be really overwhelming and confusing the first times you do them. But I want you to also understand that it's possible when you do understand what's going on mathematically, you can do it in 1 or 2 steps. Here's another one similar to the one we just did. And we're going to work this one through in as few steps as possible. Well, 4 divided by 3, there's nothing we can simplify there. So we are going to be left with a 4 and a 3 as coefficients. M to the 4th over m squared is m to the 4 minus 2, right, subtracting the exponents. Well, 4 minus 2 is 2, so we're going to get 4 times m squared in the numerator. N to the 3rd, then, divided by n squared is n to the 3 minus 2. Well, 3 minus 2 is 1, which makes sense here because we've got 3 n's multiplied together in the numerator, 2 in the denominator. So 2 pairs of them cancel out. We're left with n to the 1st power. And I'm not going to write to the 1st power because we know that n is n to the 1st power. And then this last set of terms here is p cubed over p to the 4th. Well, p cubed divided by p to the 4th is p to the 3 minus 4, which we know is p to the negative 1. So we don't want to write that as p to the negative 1 in the numerator. Instead, we want to write it as 3 times p to the positive 1 in the denominator. So 4m squared n over 3p is our final answer for that question. The next problems we're going to look at involve multiplying expressions with negative exponents together. X squared times y to the negative 4 times the expression x cubed y squared. We can rearrange this because all of this is multiplication, which means we can multiply it in any order. So I'm going to put the terms with like bases together because now x squared times x cubed I know is x to the 5th. There are 5 x's being multiplied together there. And y to the negative 4, y squared, again I can add the exponents. In this case, negative 4 plus 2, I'm going to end up with negative 2. Well, x to the 5th can stay in the numerator, but this y to the negative 2 needs to be moved to the denominator where the exponent becomes positive. So x to the 5th over y squared is our final answer. Our next example is 2x squared to the negative 4. Anytime we have an exponent outside parentheses where the stuff inside the parentheses is either multiplied or divided, we can distribute that exponent to every factor inside the parentheses. So we have 2 to the negative 4th and then x squared raised to the negative 4th power. 2 to the negative 4th we're going to write as 1 over 2 to the 4th. Now this x squared to the negative 4 term, what do we do when we have a power raised to a power? Let's think back. If we had 2 cubed squared, that's 2 cubed times 2 cubed, which is 2 times 2 times 2 times 2 times 2 times 2. Well, there are 6 2's multiplied together here. And we get 6 by multiplying 3 times 2. We multiply the exponents together. So in this case of x squared to the negative 4, we're going to get x to the 2 times negative 4, which is negative 8. And we'll rewrite that as x to the 8 in the denominator. 2 to the 4th is 16, so we have 1 over 16 x to the 8th as our final answer for that problem. Our final example today says 4r to the negative 3 times 2r squared. Well, we can rearrange this. 4 times 2 times r to the negative 3 times r squared. 4 times 2 is 8, and then r to the negative 3 plus 2, remember we add those exponents, is r to the negative 1. R to the negative 1 can be written as something over r to the 1, right? We've got this 8 hanging out here, so 8 over r to the 1 is just 8 over r. A simple answer for a somewhat complicated looking problem.